Well, tube timers were back. I was quite surprised when I opened up the bottom of this radio to realize that it's full of bees. And let me explain what I mean about that. You see these capacitors? They look so pretty and plastic. Well, inside they're not so pretty. It's just a wax and paper capacitor that has been encapsulated in a black plastic shell. These things have two common names. They are capacitors, of course, but they're also called black beauties because they're of the black, obviously the black case. And they're also called bumblebees because they just look like a bumblebee to somebody, I guess. Hence, this chassis is full of bumblebees. I have to replace them all. I mean, there's no choice. And now I'm committed because I've got to replace these things. Okay, so what are we going to start with? What did I do? Well, I got the schematic out, and I labeled or listed, highlighted all the paper capacitors, the bumblebees that had to come out. They're in yellow. The orange ones are the ones that can stay because they're mica or ceramics. Then I took a picture. And with this picture, I identified every single bumblebee, its value, and its part number. So that's how we're going to get started. Whoops, my soldering iron is not on, and it should be on full bore. Okay. So we're going to work our way from the top down to the end of the bumblebees. Alrighty, right now as we're waiting for the iron to heat up a little bit, I use the paper to identify the parts that have to be replaced. And this one is the electrolytic, by the way, which has to go. It's the electrolytic capacitor on the power side, but it doesn't seem to be a problem right now, so I'll just leave it until I get this. I'm already investing a lot of money in this thing by just replacing all these capacitors. Not to mention the time. Okay, so the very first piece we're going after is C15. It's a 0.047 microfarad capacitor. Let's see if we can get it off. Oh, this one is really stuck in there. So we're going to have to give it a little persuasion. A little bit of solder wick. The solder wick is picking up all the excess solder. And I got to do this one too because it's the other capacitor sitting there. Yeah, working with solder wick just takes a little patience and thoroughness. Ooh, I think it goes down way down under there. Suck a little more solder off. This is solder wick. It's a braided copper that's got a braided copper with a little bit of rosin on it. And the braided copper, well, the way it works is you liquefy the copper, and capillary action pulls it up the length of the braid. All right, so we're getting here. Is this the one we want? That's always the problem. Did I get the right wire? We'll see in a minute. I'm gonna heat this thing up and try to pull it out. Well, it should come right out. I don't know why it's being so difficult. Just doesn't. There we go. Just a matter of heating it up, I guess. Heating it up enough. Liquefy enough for the solder. You get the thing back into play. Okay, we've got one end of the first bumblebee out. When I'm done taking all these out, we're going to go and put them on a capacitor tester, and see what we see. Okay, a little more solder wick. I'm be a little careful here because now I'm soldering on the IF can, and I don't know if that substrate down below is plastic or if it's ceramic. I'm going to go with the assumption that it's plastic, so I can't put too much heat on it for too long for fear of melting the IF coil part, which I have done before, and it's not a not a pleasant experience, let me tell you right now. There we go. I'm not the best desolderer. I should have kludged through the whole thing. I think that's what everyone does, though, because it's kind of hard to. Well, I'm not the best desolderer. Yes, I don't know if I said soldering or not. I don't think I'm too bad at soldering, but desoldering. Well, that's got it. This is the worst right here. There we go. First one done. And this was C15. C15.047. Now we're going to clear these openings up a little bit so I can get my other lead in there. I think I've cleared an opening. Can't really tell all that well. Yeah, there's an opening there to get into. And this one here has a bit of an opening as well. So I should be able to get the new part in there. Now, before I put any parts in anything, I always like to make sure that they're good. Because the last thing I want to do is spend the time of putting in a part only to find that it is bad. I've done that before, too. And when you put a new part in as a replacement, somehow you make the assumption that it's a good part. Not always the case. I'm just going to put a little picky probe in here and see if I can open up the hole for the lead just a bit more. And I sure did. This is good. Alright, so now we get the 047 out. Here is my batch of capacitors, and the 047 we'll measure it. 4.6 0046. No, we don't want that one. What did I call the value of that, by the way? 0.7, 0.4, 0.47, 2, Here's an 047. There's the 047 right there. One of the things I like to do is install them so that the lettering is upwards, so you can see later on if you need to replace it or something like that. So let's see what we're gonna have here. Well, I guess this goes in okay. A little nervous about the exposed wire, but that's the way it is. You stick it in one side. And we attach it to the other side. This is rather interesting. This little resistor, it's a 4.7 meg, yellow, violet, green, but there's no band. So what does that mean? That means it's a 20% resistor, 20% tolerance. Huge tolerance factor. Well, it's probably in parallel with something else, so measuring it's not going to be very conclusive. But let's just take a quick look with the ohm meter. Look at that, 4.55. That's well within tolerance. That's a good resistor. Okay. So now that we have some confidence that it's a good part, we shall stick it in. Whoops! I've got this thing blocked up underneath so that you can see what's happening nice and clearly on the inside of the backplane here. But the downside is that it's a little bit woogity, and the woogity is not so much fun sometimes. Okay, so this goes in here like this. There we go. Huh. Well, that one doesn't have enough. Let's see if I can put my tool in here. My probing tool can go right into here. I can see some light through it, but I can't see enough light. So with this pointy part, I'm going to force it through. Oh, look at that. I've loosened up this one. That's a good sign. Alright, we'll stick it in and see if it flies. Oh, yes. Very nice. You can see I can feed it through. Yes, when I'm done with this assortment of mess, I'm going to have to retune the entire thing because I know I'm taking it way the heck out of tune now by changing these capacitors. Or out of alignment, I should say. Because that's what we worry about. This part and alignment. This is tough. Well, figuratively speaking, tough. There it is. Retrieve our bad cut. There we go. Well, that's probably good enough. I've given it a nice crimp here. Let's solder it in place. Okay, what's the way you solder? You apply heat, then you apply solder. And that's all she wrote. A very simple, clean joint. And we'll get to the other side. And we will simply give it a twist up to say, yep, there it is. And we'll solder this one in place. Now that we have a nice hole to stick it in, we give it a tightening just for fastening's sake. And then we solder it into place. Apply our heat, and then our solder. And that's it. Doesn't take, we don't got to put a gallon of solder on there. I probably put a little too much, but it will do the trick. First, Bumblebee excised. Here's the second Bumblebee. This fella right here. This one happens to be a, let's see, it happens to be C21, and C21 is a 0022 microfarad. All right, let's pull it out first, though, before we get excited with what the value is. Boy, someone put a ton of solder on here, way more than is necessary. Way more than is necessary. Solder is a neat thing. You don't want to use too little, but you certainly don't want to use too much. It's a waste, and it makes repair difficult. There we go. We're soldering it through. Now this one was much easier. Well, I guess it was easier to get at, too. There we go. Not quite yet. There we go. And what will we do? We'll clean off the terminal post, expose the hole very nicely, and we'll go from there. Gosh, there's a lot of solder on this one, on this particular part. And we're draining out the, there we go, we've drained out the hole very nicely. Oh, sorry you can't see it, but right down underneath here is the component. Now, here's the other end. The other end goes right to here. Another big cluster of solder and wires. And so we will, I love to watch the solder run up the wick. Yeah, I know. It's weird. Now, why am I wiggling it? Because it's going to cool. And by wiggling it, I expose which one is the, there is 1, 2, 3, 4 part wires here. Only one of them is what I want. Oh my goodness, and this looks like it's been wrapped around a couple of times. Oh yes, it has. There we go. Come on. Let's get you out of there. There we go. That's been removed most nicely. Another Bumblebee excised. This is 0022. That's the part. 0022. So now I've got to find that in my pile of capacitors. 0022. $22. 2 nanofarads. 2.2 nanofarads. And here we go. See, this is the part number, 222K, or not the part number, but the value. It's a 22 with 2 zeros to make a picofarad. So what that gives us is a 0022 or a 2 nanofarad capacitor. Check, and double check. That's what you got to do, because this is kind of funny like that. There we go. We'll put this one in here nicely. And this one gets to go into here very nicely. There we go. Feeding it through. Should I have this thing on the... No, this is just good the way it is. This is just good the way it is. And this is a nice pinch on the wire. Cut it off. Cut this little fellow off here. And that is sufficient. And this little fella here gets cut off. And then we solder both. There we go. That's a good pinch over on that. Just a good pinch over on that. We can see what the value is very nicely. All right, let's solder it in. And we apply some heat, then solder. And that's all we need. A little heat and solder. And we'll do the same on this side. A little heat, then solder. And that's all we need. And that's it. We've replaced 2 of the bee's nests that we have here. There was a bee's nest in the radio. Oh my goodness. All right. Now we'll continue with this capacitor right here. But for now, I'm going to leave you. I'm going to replace these capacitors and then come back to you when it's done. So you can take a look at what the result is. Okay, now I take a look at it with all the bumblebees exterminated from the chassis and all those yellow capacitors taking its place. Well, so far so good. Now, we're going to take a look at the old capacitors and decide if we did a good thing or not.